Now that we know what a polynomial is, we can actually complete operations with polynomials just like we would complete operations with numbers. So we can add polynomials, we can subtract polynomials, we can multiply, and we can even divide polynomials. In this video, we're going to go over how you actually add polynomials. So we have two polynomials being added, 4x squared plus 7x minus 3, and then negative 9x squared plus 2x minus 5. When you add polynomials, these parentheses are kind of irrelevant because the signs aren't going to change. Like this plus sign doesn't change anything. These parentheses are really just to divide up the two polynomials. So if you wanted to, if the parentheses confuse you, you could just completely rewrite this without the parentheses, which a lot of people will do. I think it makes it a little easier to see. And then from there, all we're going to do is just combine like terms. We've done problems like this before. We have combined like terms with all different exponents, different variables before. It's the same thing. So I'm going to start with this first term. I have 4x squared. I'm going to look in all of my other terms and see what other term has the exact same variables and the exact same exponents. So I have a negative 9x squared. Those two can be combined because they're like terms. They have the exact same variables and exponents. Once I figure out that those are my two like terms, I'm going to combine them. So I'm going to add 4 and negative 9. That's going to give me negative 5. And I just keep the term. I keep the x squared. So then I'm done with that. I'm going to cross it off. I'm going to move on to my next term. I have a plus 7x. I'm looking through all my other terms, and I find I also have a plus 2x. When I combine those, I get plus 9x. Cross them off. Then my last term, I have a minus 3 and a minus 5. Combine those, I get a minus 8. So when I simplify this, my final answer ends up being negative 5x squared plus 9x minus 8. Now let's just try one more example. In this example, they're not set up the exact same way as the last example. The last example, there was an x squared term, and then an x term, and then a constant term. So it was pretty easy to combine them. In this one, they're not in order, and there's a lot of different types of terms, so you have to be careful. I'm just going to cross off the parentheses so I don't have to rewrite it. But you can rewrite it. It might make it easier. And I'm going to circle my first term. I have 4a to the third. I'm going to look through all my other terms. Is there anything else with an a to the third? No. So that doesn't combine with anything. I'm just going to rewrite it. My next term, I have negative 2a. I look through all my other terms, and again, there's nothing else that has just an a, so that can't combine with anything. I'm just going to rewrite it. Then I have 3a squared. Then I also have a 7a squared. When I combine those, I get plus 10a squared. And then my last term, I have a minus 9. That's just by itself, so I subtract 9 at the end. This is our final answer. However, you'll see most of these answers written in standard form, so written with the largest exponent first and then in decreasing order of exponents. So I'm going to rewrite this. It's going to become 4a to the third, and then next would be the a squared term, so plus 10a squared minus 2a minus 9. And that would be your final answer.